Okay, now we are going to learn how to run an independent sample t-test. When you have two different groups and you want to compare the mean scores, then you can use an independent sample t-test to do this. Now let's look at this example. Mr. Undabi was bragging to Ms. Chotsky about the results of his students' SAT scores. She did not seem impressed. My students are surely as bright as yours. In fact, I think my students on average scored higher than yours. A bold challenge, Mr. Undabi thinks. Is the average score in Miss Chotsky's class significantly different than mine? Well, how do we find that out? By running an independent samples t-test to compare the mean scores of the two classes. So let's see how we would do that. Go, please, to your example database. And when we ran the single sample t-test, remember we isolated the class so that we only used Mr. Undabi's class. Now we have to undo that so that we make sure to include both classes. So we go up again to Data, select Cases. Now you're going to switch from If Condition is Satisfied to click on All Cases and click OK. You go back to the data and you can see that now everything is included. There's no more lines. So you can go up to Analyze and click on it. Go down to Compare Means. Go over to where it says Independent Sample t-Test and click. Now, for an independent sample t-test, you must have one categorical independent variable. Okay, that could be male, female, or in this case, it could be class, right? We have Mr. Undabi's class and Ms. Chotsky's class. And that categorical variable is labeled in SPSS as the grouping variable. So you will click on class and move it over. And now, see these question marks? You need to tell the program which groups you're talking about. So you need to click on Define Groups. Group 1 has the value of 1, right over here. Group 1, Mr. Undabi's class, has the value of 1. Ms. Chotsky's class has the value of 2. Remember I mentioned you can use any value you want because here this is where you're going to designate which groups you're looking at and what the numbers to represent those groups are. And click on Continue. Now what you also need to be able to compare the means of these two groups using an independent sample t-test is one continuous dependent variable. In this case, the continuous dependent variable are the SAT scores. And we are looking at SAT scores in October. So let's move that over to where it says test variable, which is where you would place your dependent variable. Click on Options just to check it out. 95% is good. Exclude cases, analysis by analysis. Click Continue. Then click OK. And voila! You have some more output. This looks a little bit more complicated than the single sample t-test. So let's take a look. Remember, the first thing that you want to do is make sure the n looks right. Okay, because that would be the first sign if you did something wrong. Mr. Undabi's class, n equals 20. Ms. Chotsky's class, n equals 21. That looks good. Now you can take a look at the means. For Mr. Undabi, 562.20, which is the same, of course, as the mean that we had when we ran the single sample t-test. And now we have Ms. Chotsky's scores, which are 568.0952, which you're going to round up to 568.10. So, Ms. Chotsky's class did indeed have a higher mean score than Mr. Undabi's. Now we want to find out if there is a statistical significant difference between those scores. So that's why we ran the independent samples t-test to compare these means. So the first thing you want to do is look down here where it says Levine's test for equality of variances. This is not your t-test value. This is a test that's going to tell you if you can in fact assume that there are equal variances and then use the regular parametric t-test. Here you are given an F value and you are given a p-value, which is under sig, right? Significance is the p-value. What you want here is a value greater than 0.05 because you do not want the Levene's test to be significant. You want it to not be significant. And here you have 0.316 or 0.32, and that's not significant, so you're in the clear, and equal variances are assumed. Now you scroll over, and you find your t-value, which is right under the letter t. The t-value is negative 0.282. You can report that as negative 0.28. You move over one space and you have your df, your degrees of freedom, which is 39. Now if you notice, here, usually, or in the past, your degrees of freedom was calculated as n minus 1. Well, you have two variables here, so now it's going to be n minus 2. So you have 41 minus 2 is going to give you your df of 39. Right next to that, it says sig two-tailed, and that is your p-value. That's your significance value, which is 0.780. Remember, in order to be significant, it has to be less than 0.05. 0.78 is certainly not less than 0.05, so there is no significant difference between these two test scores. Just like in the single sample t-test, you also need to calculate effect size. For this test, you're also going to calculate the Cohen's d statistic. Now, this formula is a little bit more complex. So my suggestion is to go ahead and do a search. You can go into Google and type in Cohen's d calculator. The first one that comes up is a good one. You can click on that one, effect size calculator. The information that you need to calculate Cohen's d is the mean for group 1, which we know is 562.20. You need the standard deviation for that group, which is 60.52. And then you need the same information for group 2. So the mean is 568.10, and the standard deviation is 72.51. Compute. And there you have it. Cohen's d is negative 0.088 or 0.09. Okay, and now we go back and we're going to report that. No significant difference was found between Mr. Undabi's class math SAT scores. And here you put the n is 20 for Mr. Undabi's class, and the mean is 562.20. And Ms. Chotsky's class scores, and their n is 21, the mean is 568.10, and then you report the t-value just like you did in the single sample t-test. T, then in parentheses, degrees of freedom equals, and here's the t-value, negative 0.28, and then the p-value of 0.78. Because this is not significant, you really don't need to report the Cohen's value, but you certainly can. And in this case, the null hypothesis is retained because we found no differences. All right, moving along. Now we'll move on to the paired sample t-test.